What if I told you there's an actual algorithm for learning? A guaranteed, step-by-step path to mastering something as tricky as data structures and algorithms. No more guessing, no more wasted time. Today, I'm going to show you exactly how it works.
Okay, be honest. Does this look a little too familiar? You get that burst of motivation, right? Today's the day I'm going to finally master DSA. You open up your laptop, and then it all just kind of falls apart.
Next thing you know, you're bouncing between random YouTube videos. You're trying to tackle advanced graphs when you barely remember how arrays work. You're just grinding out problems with no real strategy. And that feeling, that constant nagging feeling of being overwhelmed, yeah, that just gets worse and worse. We've all been there, and let me tell you, it's a terrible way to learn.
See, you're not just guessing. You're literally trapped. You're stuck in a maze, and every wrong turn just makes you feel more lost.
So let's call this what it is. Section 1, the DSA Learning Maze. This is the place where so many promising learners just give up.
But what if? What if it didn't have to be a maze? What if you had a map instead? A real roadmap that shows you the single most efficient path from where you are now to total mastery.
Well, that map has a name. It's called a knowledge graph. And this is the magic part, where we take all that chaos of a curriculum and turn it into a clean, logical structure that a computer and you can actually understand. Now, the specific tool for the job is something called a directed acyclic graph, or just a DAG for short. Sounds complicated, but it's not. Seriously. Just think of every topic, like arrays or linked lists, as a little dot, a node. The arrows between them are just the prerequisites, and they're one-way arrows for a reason. And that acyclic part, that's super important. It just means you can't have loops. You can't have a situation where topic A needs topic B, but oops, topic B also needs topic A. That's a recipe for disaster, and a DAG makes it impossible.
And look how easy it is to build. You make a node for, say, Python basics. Then you make another one for arrays. Well, you kind of need to know Python to work with arrays, right? So boom, you just draw a little arrow from Python basics to arrays. That's literally it. You've just created a piece of your knowledge graph.
Okay, so now we have this awesome map, but a map's no good if you don't know how to read it, right? So how do we find the actual path? How do we turn this cool-looking graph into a step-by-step plan we can actually follow?
The answer is a beautiful little algorithm called a topological sort. Its one and only job is to look at our map, our DAG, and flatten it into a single straight line, a perfect learning sequence. It guarantees that if there's an arrow from topic A to topic B, you will always learn A before B. No exceptions. This isn't just a suggestion. It's our guaranteed, optimal learning path.
So how's it work? Well, one popular way is called Kahn's algorithm, and it's so logical you could figure it out yourself. First, it just looks for all the topics that have zero prerequisites, the absolute starting points. It throws them on a ready-to-learn list. Then it grabs one, puts it into your final study plan, and here's the cool part. It digitally erases the arrows pointing out from that topic. When it does that, other topics might suddenly have no more prerequisites left, so they get added to the ready-to-learn list. And you just repeat that over and over until every single topic is perfectly lined up in your plan.
And get this, it's lightning fast. The efficiency is what we call O of E plus E. Now, don't let the notation scare you. All that means is that the time it takes to run is directly proportional to the number of topics and prerequisites. So if your curriculum gets twice as big, the algorithm takes about twice as long. It doesn't grind to a halt, it scales beautifully. You could feed it a massive curriculum and it would spit out your perfect plan in a blink. All right, this is huge. We have our perfect, ordered list of topics. But a list isn't a schedule, is it? We need to make this real. We need to turn this path into an actual weekly plan that fits into our busy lives.
Because let's be real for a second. An ordered list is amazing, but life gets in the way. We don't have unlimited time. We have maybe 10 hours a week if we're lucky. So we have to work with that.
And there's one more piece to this puzzle, and it's a big one. Actually remembering what you learn. It's no good learning something if you forget it 2 weeks later, right? That's where spaced practice comes in. It's a proven technique. Basically, after you learn a topic, you schedule quick reviews at set times in the future, like a week later, then 3 weeks, then 7. These little check-ins are scientifically proven to lock that information into your long-term memory.
So what's the final output? Well, it looks something like this. Here's a plan for someone who has 10 hours a week to study. You see in week 1, they're on Python basics. Simple enough. But look at week 2. They're learning arrays and doing a quick review of Python.
Fast forward to week 4, they're learning stacks and queues, but also reviewing arrays to keep it fresh. See how it works? It's a real balanced schedule that fits new stuff and old stuff all within your time limit.
So, when you put it all together, the knowledge graph is your map, the topological sort to find the path, and the spaced practice for your schedule, what you get is an expert-level, guaranteed strategy for learning.
Now, you've probably heard this before. People say, just grind it out. More hours always beats a fancy plan. You know, the whole brute force approach.
Yeah, that's just wrong. Completely false. Smart sequencing, a good plan, is way more efficient. Why? Because you never waste time. You're not stopping in the middle of a hard problem to go relearn a prerequisite you forgot. It cuts out all that rework and lowers your mental stress, so you can pour all your brain power into the new concept.
And that's the beauty of this whole method. It comes with guarantees. You're guaranteed to avoid dead ends. You get a repeatable, solid plan every single time. It'll even tell you if a curriculum is broken because of some circular logic. And, best of all, it automatically builds that long-term retention right into your schedule. No guesswork needed.
So I want to leave you with this thought. Your learning journey isn't a random walk in the dark. It's a graph, and a graph can be solved. Every topic is just another node waiting to be unlocked. So the only real question is, what's the next node you're going to conquer?